All right, day 4. I'm really late. I've had a really busy week, so I'm just trying to catch up on the days. Hopefully, get back to it the rest of the week. Okay, guys, day 4. You ride the escalator down to the printing department. They are clearly getting ready for Christmas. They have lots of large rolls of paper everywhere, and there's even a massive printer in the corner. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole base while the elevators are offline. Actually, maybe we can help with that. One of the elves replies when you ask for help. We're pretty sure there's a cafeteria on the other side of the back wall. If we could break through the wall, you'd be able to keep moving. It's too bad all of our forklifts are so busy moving these big rolls of paper around. If you can optimize the work the forklifts are doing, maybe they would have time to spare. They would have time to spare to break through the wall. The rolls of paper, the ats, are arranged on a large grid. The elves even have a helpful diagram. Your puzzle input. This. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper. Wait, so these are the rolls of paper. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. Okay. In this example, there are 13 rolls that are accessible. Fewer than 4. So here there is 1, 2, 3, 4, 5, 6, 7. Yep, no good. Okay, so yeah, it's like a coordinate type thing. There's 13 rows. Okay. This part is fine. I'm gonna do it in JavaScript because I just did a whole day in OCaml and it humbled me. So let's do day 4. Yeah. And we can put .txt here for our actual thing. And we can run index.ts /watch. Well, the flag has to come first. No? Oh, wow. Okay. Okay, great. So let's just put this in here. Let's go into here. Run.file. Input.txt. Content equals file.text. And we can organize that into a grid. So let's just do const grid equals this, or actually content.split at the new lines dot map each one into L dot split is used separate if omitted a single element array containing the entire string is returned. How do I iterate through a string? How do I do that? Actually, JS string to array. Split with nothing. Nope. Oh yeah, there it is. So then dot map c. C is equal to dot, then actually it doesn't matter, we can leave it like this. Let's go like this, or empty, and we go like paper. And one thing I like to do for this type of problems is actually pad everything. So actually, I'm going to do is I'm going to pad the list like this. And I'm going to do const line size equals content at 0 dot length, and we go dot repeat line size, and the same here. Isn't that nice? This is horrifying code now, but hey, it's okay. We can get rid of this first one. There we go, look at, oh, that's not padded, is it? Split content. Okay, nice. So that's now padded. Great. So now we go for let I equal. I need brackets here. I is smaller than grid.length minus 1. Yeah. So you pad it so that you don't have to do the checks for out of bounds, which is nice. But we might have to for part 2. We never know. Like this. And then all we do here is for each one, let's go like okay, fine. I can actually do a equals minus 1. A is smaller than 2. Smaller than or equal to 1. A plus plus. We go B, B, B. If A is equal to B. Continue. So then const tile. I'm gonna go square. Call it square. Grid at J. I J plus B, I plus A. If square is equal to paper, let adjacent papers equal 0. Adjacent papers plus plus. Why is this a square bracket? And we go part 1 once if there are fewer than 4. Okay. Wait, hold on. This variable is not unused. Let's adjacent paper square equals paper. 54. really, really strange, actually. Let's double check that we have done this right. So J is actually the, let's change this X and Y. So if we go along, that's X. Oh, so it's the other way around, whoops. So this here is X. Let's call B X offset, A offset. Mm-hmm. 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 Yeah, okay. Well, what's wrong? Okay, so it thinks that that top one works. Oh, but it's, oh, oops. If, I see. Hmm. Okay. 33? Why? It's not 33. Let's actually do this so that we can get like the same here on our editor. What? 1, 2? Isn't that empty? Or there, am I being a bit silly here? I think I might just be printing them wrong, actually. The other way around. But it should really be going this way, right? Or are we checking this way first? No. We're checking, oh, come on, man. This is not the time to get started. Oh, that's why. Offset. Why would it let me name it to that? Oh my god. Grid of this, okay. 1, 3. And now I can actually print this the right way around, so. So it does go to 10. It thinks that 9 is fine. Yeah, there's 1, 2, 3, 4, 5 in this. This says 9. This says 1. It doesn't pick up 1, 3. Should it pick up 1, 3? It should. It picks up 1, 4. Why didn't it pick up 1, 3? We're just doing the grid wrong, for sure. Let's just go process.standardout.write. Okay, yeah, that's correct. That's all fine. The current square is empty. It doesn't matter. Grid of y plus the y offset, x plus the x offset. If that square is equal to adjacent paper, if we have less than 4, we add it to part 1. What is wrong then? Why do I always get stuck in these stupid things for too long? Okay, well now it's printing 1, 3. Oh, maybe I didn't scroll up enough. 1, 4. Okay. But it's too many, way too many. Say like 4, 1. Oh no. It's not that if they're equal, it's if they're 0. Oh, you're so silly. Now we get 22, which is significantly less, but still. Yeah, that was definitely part of it. Now we're still getting more. Why? Because the y offset goes from -1 to 0 to 1. Less than or equal to 1. Yep. And we're checking adjacency there. Yep. Current square is empty. We continue. Let's just check 1, 1, 3. Let's go like, which one did it think it is? So like 8, 1. 8, 1 is fine. Y 11. I don't understand why it would go to, why I would think Y11 is correct though. Undefined. Ooh. That's no good. I mean, great, but I'm not sure why that works. I think it's something to do with this here, right? What's our grid? Grid is fine, but we're accessing something out of the bounds there. Grid Y, Was it smaller than grid.length minus 1? Weird. Actually, really strange. But we got our answer. Wait for our answer. We got our answer way too slowly. 1 1 1 4 4 1 4 4 5 even. Nice. Part 2. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed by a forklift, it can be removed. Once a roll of paper is removed, the forklift might be able to move more. Okay, so the initial state is here. We remove those 13. Remove. Okay. So it's basically this, but with a very deep copy. So let's go. Let's go const solve, which takes in a grid, which is a thing like that. And we go turns, which is a number. Not that. I always get those wrong, funny enough, on the shift on this keyboard. Let turn equals 1, whilst turn is smaller than turns, or equal to. Actually, let's make that turn plus plus. Hold on. So we do turn. Now let's do one turn, right? So let's do solve, which is, and then it's going to return a tuple of number and the actual grid. So down here we're going to return the part 1 grid. Not part 1 anymore, it's not called part 1. Should be paper removed. And we go, if we were able to remove it, we actually go grid y x equals empty. Because we're just moving to the right. Oh no, okay, no, we can't do that. So let's go like new grid, which is gonna be structured clone of grid, and only here we actually go, if we were able to move it, we go new grid, part 1. Actually, and now we go like remove paper, grid string turns number, returns the total number of things removed, and here we go for let turn equals 0, turn smaller than turns. We go paper removed, total paper removed equals 0, new grid equals solve with the grid, copied grid equals structured clone of the grid, copied grid there. Actually, let's just assume it passes in a fresh copy. Fresh copy, we copy. No, you can just pass in a current grid, and then we go current grid equals new grid. Total paper removed plus total paper removed. Okay. And oh, it's not actually what we want. This thing. It's kind of what we want, but we don't want turns. Let's just go while true. If paper removed is equal to 0, break. Eight 317. Oh well. Oh, one shot it. Oh, beautiful. I love it when that happens. It's rare, but it's nice. That wasn't too bad. I should have solved it way sooner. I don't know. This thing here is still holding so much weight. But yeah, nice, good day. Thank you for watching, and I'll catch you in the next one.